Hello again. Wow, look at this. We're now at assignment 16. This is crazy how many assignments you've done. I know this is probably the feeling that a lot of you have right now. So much homework, so little motivation. Stick with it. We just have a couple more lessons. I know that it's hard, but keep going. I'm trying to make the assignments short, the last few here. So get them done. I've got to think of something to reward the people who get every single assignment done. It's a pretty incredible achievement. All right, so today we're going to do surface area of cylinders. Remember last day we talked about, or last lesson, I actually made these videos the same day, but we talked about surface area and we did surface area of prisms. We said that surface area was the total area of all the faces in a three-dimensional object. And last time we looked at rectangular prisms and triangular prisms and cubes. Today we're just going to do one more. We're going to do the cylinder. Let's get right to it. Here's the cylinder. Now, here is a question for you. Which three basic shapes make up a cylinder? There's actually only three shapes, basic shapes that you know of that make up the cylinder. Now, I'm hoping you can see two of them. Two of them are exactly equal to each other. Do you see them on the top of the bottom? You have two circles. There's definitely two circles in, there they are, two circles. Okay, now think of imagine this was a toilet paper roll. Empty toilet paper roll, right? So the circles are gone now because toilet paper roll is open at the ends. What would happen if I took a pair of scissors and I cut it? I would do this if we were in class together. I would show you this. If I cut the cylinder, because it is a cylinder, if I cut it right there and I open it up, what shape would you be left with? Oh my gosh, you know what it would be? It would be a rectangle. You would actually get one rectangle as well. Okay, so we need to find the area of these two circles and the area of this rectangle, and we'll have the total formula. So I'm actually going to give you a formula this time. Yesterday I didn't. Some of you might have been pining for a formula. I don't give you one for rectangular prisms and triangular prisms. There is one for rectangular prisms, but I figure it's better just to learn the procedure. I think it's going to serve you well to do that. All right, so let's do this. Two circles. We want to find the area of both of those. Well, do you remember what the area of a single circle is? The area of a circle is pi r squared, where r is the radius, right? It's from the middle of the circle to the outside is r. But wait a minute, that's for one circle. We have two. Well, that's no problem. We're just going to multiply it by 2. So we have 2 pi r squared plus, and I'm just going to make a note of it. This, the 2 pi r squared, this is the area of the two circles. Okay, now we're going to have some other piece, which is the rectangle. But I'm not going to say the rectangle because when you look at this, you don't say the rectangle. I'm going to call this the, what do I call it? The soup label. You know, on a can of soup, there's the label. I'm going to call it the soup label. Or you could call it the toilet paper roll or something. Or call it the rectangle. Maybe that's the best of all. All right, so we need to figure out how to get the area of this. And you could just say, well, it's a rectangle, length times width. But wait a minute, length and width, we're not going to be given those values in the cylinder. It doesn't make sense. What they're going to give you in the cylinder is the radius, or maybe the diameter. But anyway, the radius, and they're also going to give you the height of this thing. So if you unrolled this, I'm going to redraw it so it looks more like this. It'd be a little taller, wouldn't it? Something like this. If you unrolled this cylinder, what's this distance right here? That's the h. Okay, that's the h right there. Okay, here's the tricky part. What's this distance right here? Well, that is the entire distance around there. All that together, if you unroll it, that red curve there becomes this straight red there. What do we call that red thing? That's all the way around the circle. We haven't talked about this in this class, I don't think. Do you know what all the way around a circle is called? It's called the circumference. Circumference. And does anyone know the formula for circumference of a circle? What most people know it to be is pi times diameter. And that's true. But look, we already have an r in our formula. Why don't we, instead of having a r and a d, why don't we put it all in terms of d? I mean, sorry, all in terms of r. I mean, you could put pi d here, and this would be an acceptable formula. 2 pi r squared plus pi d. But what I prefer, and most people prefer, is to actually have this part of the formula also with an r in it. So what's d? D is the whole way across. R is only halfway across. So instead of putting d, how many r's do you need? Instead of having one d that goes all the way across, you would need two r's. 1, 2. So instead of having d, let's put 2r. But let's also change the order. So let's make it 2 pi r. So that's how much this distance is here. Oh, so instead of going length times width, we're actually going to go 2 pi r times h. So this part here is 2 pi rh. This is your formula for surface area. Did you follow all that? Maybe not. If not, just know that this is the formula that you're going to use to find the surface area of a cylinder. Alright, so we're getting the surface area of this cylinder. So before I do anything else, I really think I should write down the formula that I just wrote down. It was 2 pi r squared plus 2 pi rh. And really this just becomes a entering in numbers in here. 2, pi, well pi is a number, so I just put pi. R, that's the radius. What's the radius of this cylinder? Well, you look at the circle and the radius is 3. So I'm going to have 3 squared plus 2, pi, r, we already did r is 3, but don't square it this time. It's not squared, it's just r. And then h, how much is h? 8, that's the height, right? It's 8. Alright, you could just pick up your calculator and hammer this in, but I do find that a lot of times people get it wrong if they do that, so be careful, use some brackets and stuff if you're going to do that. What I prefer to do is get this answer, and then add them together. So in this one, remember you're going to square it first. So I'd have 3 squared, which is 9, times 2 is 18. So I have 18 pi plus 2 times 3 is 6 times 8 is 48. So now I have 48 pi. Any ideas what 18 pi plus 48 pi is? You just add them together, 18 and 48, and you get 56, and it's still pi. If you have 18 of these pies and 40, I mean, think of a literal pie if you want. I have 18 pies, and then my mom brings home 48 more pies. How many pies do we have now? We have 66. I don't know why I have 56 there. It should be 66. Sorry. So that's a great answer, 66 pi. However, in your workbook, they're not going to do that. They're going to actually take 66 and multiply it times 3.14. Or, even better, use your pi button. And if you do that, if you go 66 times 3.14 or use the pi button, you'll get 207, I'm going to do it to one decimal place, 0.3, and it doesn't have units. Oh my gosh, let's put meters in meters just so I can put something. Remember what we do for surface area? It's surface area, and area is squared. So there you go. Okay, I don't even know if I should do this one. It's pretty well almost the same thing. Let me just make a point here. What if this cylinder, it was closed here, but it was open on the top? It was like a drinking glass. Would that impact this part of the equation? No, because that's the soup label. Would that impact this part of the yes, it would impact this part of the equation because this was for 2 circles. Now we'd only have 1 circle down here that we could paint, right? That has an area. There's no area here. You can't paint this because it's an open thing. So you wouldn't have 2 pi r squared. It would now be pi r squared plus 2 pi rh. Okay, similarly, what if I told you that this one down here also wasn't actually here? So it's a completely open tube. It's a toilet paper roll with no paper on either end. Would that impact this? No, that's the soup label or the toilet paper roll. Would that impact this? Yeah, that's both circles and we don't have any. So now this would be the whole formula. By the way, this is called the lateral area, but you don't have to worry about that. But that part there is called the lateral area. If you're doing this question, you write down your formula, You go 2 times pi times the radius. 8? No. 8 is the diameter, which is the whole way. So you'd actually make it half as much. It'd be 4 for the radius. So then you have your 4 squared plus 2 pi. There's the radius again, which we already said was 4. And the height is that 12? I guess it's 12, yeah. Okay, if I multiply, I'm going to square this first and get 16. Times 2 is 32, so I got 32 pi. I'm doing this one fast. This is exactly the same as the last one, just different numbers. 2 times 4 is 8, times 12 is 96, so we get 96 pi. If I add 32 pi and 96 pi together, I get 128 pi. Great answer. If you want it to match the workbook, then you're going to multiply it by 3.14, or again, use the pi button, and you'll get 402.1 inches squared. All right, great. Let's go on to this last one. Uh-oh, what's this? It's only half of a cylinder. So let's write down our formula. Surface area equals 2 pi r squared plus 2 pi rh. So this is an interesting question. It's a tough question. So how are you going to start? If you were doing a volume question for this, what would you do? You'd get the volume of the whole thing, and then since it's only half a cylinder, you just divide it by 2, right? You're going to start by doing the same thing, but you got to do something else at the end. So let's see if we can figure this out. So let's pretend this is an entire cylinder. Yeah, it's not bad. Imagine it's a whole cylinder. And let's find the surface area of the whole cylinder. So we have 2 times pi times the radius. Again, this 10's the diameter. We got to do half, so it's going to be 5 squared. Plus 2 times pi times 5, because that's the radius again, and the height is 12. Height doesn't always mean up and down, right? This thing's lying down like this. The height is just this dimension here. All right, 5 squared is 25 times 2 is 50, so we got 50 pi, plus 2 times 5 is 10 times 12 is 120 pi. And if you add those together, you get 170 pi. All right, great. But that's for the whole cylinder. We don't have a whole cylinder. We have half a cylinder. So we should take that answer and we should divide it in 2, and we get 85 pi. So is that our answer? No. Can you figure out why that's not the answer? I'll give you a hint. Think about surface area again as when you're painting the outside of something. So yeah, we could paint all this curved part here. We could paint there. We could paint there here as well on the other end. But do you see what else you can paint? You can now paint the underside of this cylinder, which happens to be a rectangular shape. You could now paint this down here. So you need to figure out the area of that flat part on the bottom, that rectangle, and you need to add that on as well. So it's a rectangle. We know it's going to be length times width. So it's 10 times 12, which is 120. So now to get the total surface area, you have to add your 85 pi, which you got here, and your 120, which you got there. You can't actually add those together because this has pi's and this doesn't. So this would be your answer in grade 11 and 12. You'd be done right there. But I tell you what, let's change our 85 pi into a grade 8 answer. In other words, multiply by 3.14, or better yet, use the pi button. I get 267.0. Don't even need to put the 0.0, I suppose. So where it says total surface area, I'm going to do 267 plus 120, and that gives me 387. We're talking about inches squared. Okay, pretty tricky question. That's a thing about surface area. When you cut stuff and you're doing volume, all it does is divide by 2 or whatever. But with surface area, it exposes new surfaces, and so it means you have to take that into account. You think this is hard? Wait till next day. We're going to end this course with a grand finale. So hard. Wait for it, people. All right, today's assignment. Okay, so again, it's assignment number 16. It's going to be due Monday, June 8th. And the assignment's from your workbook. You actually worked on these pages before, did these questions before. Before you did it with volume, now you're going to go back and do surface area using the formula that we just learned today. Okay, let me know if you have any questions. As this lovely child says, stay strong. School year's almost over. I know you people can do it. You're doing well. All right, take care and goodbye.